Good afternoon. Population protection. Table of contents. Introduction. Population protection, which includes blast shelters, fallout shelters, and how gas masks work. Evacuation. The work of the civil defense during peacetime. Effective civil defense measures have the potential to reduce drastically casualties and economic damage in the short term and to speed a nation's economic recovery in the long term. Civil defense seeks to preserve lives, economic capacity, post-attack viability, and pre-attack institutions, authority, and values. The extent to which specific civil defense measures would succeed in doing so is controversial. Population protection. Civil defense seeks to protect the population, protect industry, and improve the quality of post-attack life, institutions, and values. This section considers several measures that support these goals. People near potential targets must either seek protective shelter or evacuate from threatened areas to safer surroundings. If not at risk from immediate effects, they must still protect themselves from fallout. Both forms of protection depend on warning, shelter, supplies, life support equipment, instruction, public health measures, and provision for rescue operations. In addition, evacuation involves transportation. This section examines each form of protection. Blast shelters. Some structures, particularly those designed for that purpose, offer substantial protection against direct nuclear effects like blast, thermal radiation, ionizing radiation, and related effects such as induced fires. Science blast is usually the most difficult effect to protect against. Such shelters are generally evaluated on blast resistance, and protection against other direct effects is assumed. Science's most urban targets can be destroyed by an overpressure of 5 to 10 psi. A shelter providing protection against an overpressure of about 10 psi and called a blast shelter, although many blast shelters offer greater protection. Other shelters provide good protection against fallout, but little resistance to blast. Such fallout shelters are discussed. Blast shelters generally protect against fallout, but best meet this purpose when they contain adequate life support systems. For example, a subway station without special provisions for water and ventilation would make a good blast shelter, but a poor fallout shelter. Nuclear explosions produce rings of various overpressures. If the overpressure at a given spot is very low, a blast shelter is unnecessary. If the overpressure is very high, direct hit with a surface burst, even the best blast shelters will fail. The harder the blast shelter, that is greater the overpressure it can resist, the greater the area in which it could save its occupants' lives. Moreover, if the weapon height of burst is chosen to maximize the area receiving 5 to 10 psi, only a very small area or no area at all receives more than 40 to 50 psi. Hence, to attack blast shelters of 40 to 50 psi, which is a reasonably attainable hardness, Weapons must be detonated at lower altitude, reducing the area over which buildings, factories are destroyed. The costs of blast shelter depend on the degree of protection afforded and on whether of shelter is detached or is in a building constructed for other purposes. However, a large variation in costs occurs between shelters added to existing buildings and those built as part of new construction. The installation of shelters in new construction or slanting is preferable, but it could take as long as 20 years for a national policy of slanting to provide adequate protection in cities. An inexpensive way to protect population from blast to use existing underground facilities such as subways where people can be located for short periods for protection. If people must remain in shelters to escape fallout, then life support measures requiring special preparation are needed. Other lethal nuclear effects cannot be overlooked. Although, as noted above, blast shelters usually protect against prompt radiation, the shelters must be designed to ensure that this is the case. Another problem is protection against fallout. If a sheltered population is to survive fallout, two things must be done. First, fallout must be prevented from infiltrating shelters through doors, ventilation, and other conditions. Other measures to prevent fallout from being tracked or carried into a shelter must also be taken. More important, the shelter must enable occupants to stay inside as long as outside radiation remains dangerous. Radiation doses and cumulative and a few brief exposures to outside fallout may be far more hazardous than constant exposure to a low level of radiation that might penetrate into a shelter. Science radiation may remain dangerous for periods from a few days to several weeks. Each shelter must be equipped to support its occupants for at least this time. Requirements include adequate stocks of food, water, and necessary medical supplies, sanitary facilities, and other appliances. Equipment for controlling temperature, humidity, and air quality standards is also critical. With many people enclosed in a air-raid shelter, temperatures, humidity, and carbon dioxide contents increase, oxygen availability decreases, and fetid materials accumulate. Surface fires, naturally hot or humid weather, or crowded conditions may make things worse. If unregulated, slight increases in heat and humidity quickly lead to discomfort. Substantial rises in temperature, humidity, and carbon dioxide over time could even cause death. Fires are also a threat to shelters because of extreme temperatures, a possibility exceeding 2000 by Fahrenheit, and carbon monoxide and other noxious gases. A large fire might draw oxygen out of shelter, suffocated shelters. World War II experience indicates that rubble heated by a firestorm may remain intolerably hot for several days after the fire is put out. Fallout shelters. In the United States, fallout shelters have been edified predominantly in urban areas. The Defense Civil Preparedness Agency (DCPA) shelter survive to protect against fallout from distant explosions. In case of Russian attack on USA intercontinental ballistic missiles. On the other hand, Russian fallout shelters are primarily intended for the rural population and an evacuated urban population. Fallout protection is relatively easy to achieve. Any shielding material reduces the radiation intensity. Different materials reduce the intensity by differing amounts. For example, the thickness, in inches of course, of various substances needed to reduce gamma radiation by a factor of 10. Steel 3.7, concrete 12, earth 18, water 26, wood 50. Consider an average home basement that provides a protection factor. Increase the level of radiation to 1/10 of that outside. Without additional protection, a family sheltered here could still be exposed to dangerous levels of radiation over time. For example, after 7 days, an accumulated dose of almost 400 rains inside the basement would occur if the radiation outside totaled for thousands Röntgens. This could be attended to a relatively safe accumulation of 40 Röntgens if about 11 inches of dirt could be piled against windows and exposed walls before the fallout begins. 36 inches on dirt would reduce the dose of negligible level of 4 Röntgens. Thus, as DCPA knows, fallout protection is as cheap as dirt. Moving dry, unfrozen earth to increase the protection in fallout shelter requires considerable time and effort if done by hand. A cubic foot of earth weighs about 100 ounces. A cubic yard about 2.7 ounces. Given time, adequate instruction, and the required materials, unskilled people can convert home basements into effective fallout shelters. The overall effectiveness of a fallout shelter therefore depends on having an adequate shelter or enough time, information, and materials to build, to improve, and expand the shelter. Having sufficient food, water, and other supplies to enable shelterers to stay sheltered until the outside fallout decays to a safe level. They may need to remain in shelters for periods ranging from a few days to over 1 month, depending on fallout intensity, and entering the shelter promptly before absorbing much radiation. Over the years, home fallout shelters have received considerable attention, with the government distributing plans that could be used to make home basement better shelters. Such plans typically involve peeling dirt against windows and on floors above the shelter area, stocking provisions, obtaining radios and batteries, building makeshift toilets, and so forth. Such simple actions can substantially increase protection against radiation and may slightly improve protection against blast. However, few homes in the south and west have basements. With adequate time, instructions, and materials and expeditions, shelter offering reasonable radiation protection can be constructed. This is a buried or semi-buried structure, shielded from radiation by dirt and other common materials. Expanded shelter construction figures prominently in Russian civil defense planning. How gas masks work? Anytime there is a threat of biological or a chemical attack, the first thing you hear about is gas masks. Gas masks, more generally known as respirators, are also an important part of industrial safety on a daily basis. They protect workers against everything from flour, dust in a grain elevator to the damaging organic chemicals in a paint spray. Types of gas masks. When most people think about gas masks or respirators, what they usually envision is tight-fitting plastic or rubber face mask with some sort of filter cartridge. The mask covers the nose and mouth. These are called half mask and air purifying respirators. Depending on the chemical or biological agents in the environment, a half mask may not be sufficient because the eyes are very sensitive to chemicals and offer an easy entry point for bacteria. In this case, a full face respirator is called for. It provides a clear face mask or clear eye pieces that protect the eyes as well. A typical full-face air purifying respirator used here with a hood and suit for extra protection. Air purifying respirators have two advantages. They are the least expensive option. They are the least complicated option. The problem with air purifying respirators is that any leak in the mask makes them ineffective. The leak could come from a poor fit between the mask and the user's face or from a crack or hole somewhere on the mask. Two other types of respirator systems solve the leak problem. The supplied air respirator uses the same sort of filter cartridge found in air purifying respirator. However, instead of placing the filter directly on the mask and requiring the user's lungs to suck air through it, the filter attaches to a battery-operated canister. The canister uses a fan to force air through the filter, and then the purified air runs through a hose to the mask. The advantage is that the air coming into the mask has positive pressure. Any leak in the mask causes purified and from the canister to escape rather than allowing contaminated air from the environment to enter. Obviously, positive pressure creates a much safer system, but it has two disadvantages. If the batteries die, so do you. The constant airflow through the filter means that the filter does not last as long. However, for infants and children, this may be the only option because their small faces make masks difficult to fit reliably. The best system is called an SCBA, Self-Contained Breathing Apparatus System. SCBA. If you have ever seen a firefighter wearing a full face mask with an air tank on his or her back, then you have seen an SCBA system. The air tank contains high pressure purified air and is exactly like the tank used by a scuba diver. The tank provides constant positive pressure to the face mask. And SCSBA provides the best protection, but has the following problems. The tanks are heavy and bulky. The tanks contain only 30 or 60 minutes of air. The tanks have to be refilled using special equipment. SCBA systems are expensive. For firefighting, the SCBA system makes a lot of sense. The smoke is thick, dangerous, and contains an unknown mix of poisonous gases. The fire may consume most or all of the oxygen in the air. The fire engine can carry extra tanks or refilling equipment, and firefighter spends a limited time in a burning building. For civilians or for soldiers on the battlefield, however, an SCBA system is nearly impossible to manage because of the expense and the limited air time. How filters work? Because of the problem with SCBA system, any respirator that you are likely to use will have a filter that purifies the air you breathe. How does the filter remove poisonous chemicals and deadly bacteria from the air? An air filter can use one or more of three different techniques to purify air: particle filtration, chemical absorption or adsorption, chemical reaction to neutralize a chemical. A typical disposable filter cartridge for a respirator. When you inhale, air flows through the inlet through a particulate filter, through an activated charcoal filter, through another particulate filter to trap charcoal dust, and through the outlet on the right into the mask. When the particulate filter clogs or the activated charcoal becomes saturated, you must replace the cartridge. Particle filtration in the simplest of the three. If you have ever held a cloth or hand over your mouth to keep dust out of your lungs, you have created an improvised particulate filter. In a gas mask designed to guard against a biological threat, a very fine particulate filter is useful. An anthrax bacteria or spore might have a minimum size to 1 micron. Most biological particulate filters remove particle size as small as 0.3 microns. Any particulate filter eventually clogs, so you have to replace it as breathing becomes difficult. A chemical threat needs a different approach because chemicals come as mists or vapors that are largely immune to particulate filtration. The most common approach with any organic chemical, whether it is paint, fumes, or a nerve toxin like sarin, is activated charcoal. Charcoal is carbon. Activated charcoal is activated charcoal is charcoal that has been treated with oxygen to open up millions of teeny pores between the carbon atoms. According to Encyclopedia Britannica, the use of special manufacturing techniques results in highly porous charcoals that have surface areas of 300 to 2000 square meters per gram. These so-called active or activated charcoals are widely used to absorb odorous or colored substances from gases or liquids. The word adsorb is important here. When a material adsorbs something, it attaches to it by chemical attraction. The huge surface area of activated charcoal gives it countless bonding sites. When certain chemicals pass next to the carbon surface, they attach to the surface and are trapped. Activated charcoal is good at trapping carbon-based impurities, organic chemicals, as well as things like chlorine. Many other chemicals are not attracted to carbon at all. Sodium and nitrates, to name a couple, so they pass right through. This means that an activated charcoal filter will remove certain impurities while ignoring others. It also means that once all of bonding sites are filled, an activated charcoal filter stops working. At that point, you must replace the filter. Sometimes the activated charcoal can be treated with other chemical to improve its absorption abilities for a specific toxin. See this page. The third technique involves chemical reaction. For example, during chlorine gas attacks in World War I, armies used masks containing chemical designed to react with and neutralize the chlorine. According to this page, destruction by chemical reaction was adopted in some of the earliest protective equipment such as the hypo helmet of 1915. Chlorine was removed by reaction with sodium thiosulfate, and in the British and German masks of 1916, phosgene was removed by reaction with hexamethyl tetramine. Evacuation. Evacuation is conceptually simple. People move from high risk to low risk areas. In effect, evacuation or crisis relocation uses safe distance for protection from immediate nuclear effects. The effectiveness of crisis relocation is highly scenario dependent. If relocated people have time to find or build shelters, if the areas into which people evacuate 1 minute coffee break. Ага. Алло. Да. Нет, нет, я читаю лекцию просто сейчас. Я перезвоню. So, once evacuated people must be sheltered. They might be assigned to existing public shelters or to private homes with basements suitable for shelter. If materials are available and time permits, new public shelters could be built. Evacuees require many of the some life support functions described previously under fallout shelters. Providing this in sufficient quantity would be difficult. Evacuation entails many unknowns. The time available for evacuation is unknown but extremely critical. People should be evacuated to areas that will receive little fallout, yet fallout disposition areas cannot be accurately predicted in advance. Crisis relocation could increase the perceived threat of nuclear war, and this might destabilize a crisis. Whether people would obey an evacuation order depends on many factors, especially public perception of a determining international crisis. If an evacuation were ordered and people were willing to comply with it, would time allow compliance? If the attack comes while the evacuation is underway, more people might die than if evacuation had not been attempted. Sufficiency of warning depends on circumstances. Of US President might order an evacuation only the Russians had started one. The success of evacuation in the United States would likely vary from region to region. General evacuation requires little planning in sparsely populated areas. In some areas, especially the Midwest and South, evacuation is feasible but requires special planning because fallout from attacks on might mean longer evacuation on distances. The work of the civil defense during peacetime. First one, providing relief to the affected people in emergency situation. The second one, training the volunteers to carry out the acts of civil defense. The third one, organizing the rules and the main means of industrial safety and security. Fourth one, firefighting, fire extinguisher, rescue and ambulance. 5. 1. Establishing operating rooms, centers for civil defense, and identifying the necessary specification and supervisions of the shelters to protect the population. 6th one, creating and preparing the civil defense formations of different measures and processing it with the necessary equipments and means. 7th one, storage of various materials and equipment necessary to sustain life in war, emergencies, and disastrous situations. 8th one, the preparation and implementation of the necessary action that aims to achieve safety and to avoid disasters and to remove its effects in addition to providing cash subsidy. 9th one, use the media to achieve the objectives of civil defense. And 10th one, implementation of the plans of evacuation and accommodation in emergency cases. Public health response to disaster. Medical providers must understand the impact of disasters on the public health infrastructure in order to have an efficient medical response. The challenges related to these tasks are twofold. The rapid needs assessment must be performed concurrently with the provision of the medical services. Planning the response will be based of necessary on limited assessment information. They provide timely evaluation of the impact of the disaster on the affected population. The three specific elements of the rapid needs assessment are described now. 1. Assessing the magnitude of disaster. Media reports can provide valuable information regarding the magnitude of a disaster, particularly in the area of greatest impact. The ability of reporters to gain first-hand operational information through helicopter and fixed-wing aircraft reconnaissance can provide visual information that can be used to estimate damage caused by the disaster. The second one, assessing lifeline services. Lifeline services minimum requirements: water, portable, increase by 20 liters per day. Sanitation, 5 liters per day to one person. Food, adult, 1.9 kilocalories person per day. Children, various age. Emergency temporary shelter, 3.5 square meter person. Thanks for your attention.